I want to show you how to render objects like this because you need them in multivariable in integrals. So the question, there could be one or two questions that I'm going to look at today. It says find the volume of the following solids. One solid is under the paraboloid, c equals x squared plus y squared, above the xy plane, and inside this cylinder, x squared plus y squared equals 2x. The other one is going to be a solid. The solid we're going to look at is inside the sphere and outside the cylinder. To find the volume, we're going to use double integrals, or even triple if you want. I wanted to show you how to render these. So what I've got here is the first one. So let's review the first one. Under the paraboloid, above the xy plane, inside the cylinder. So the paraboloid is here in gray. If you just graph that by itself, you have this. Okay, so the cylinder is here. I'm going to extend it to 3D. It's probably going to do that anyway. And what we're looking for is how to find this little intersection here. So to do that intersection, what I've done is I went up to this. I went up to the edit list here, and I just did copy this, and then I added the cylinder equation. Okay, and that's it. I put it in brackets. These brackets represent the idea of piecewise defined function. So it's this function with this restriction on it. All right. So what I did was I graphed the paraboloid, I graphed the cylinder, and then I said, oh, okay, I only want the part of the paraboloid that's on the cylinder. The part of the paraboloid that intersects the cylinder. So I did this piecewise defined function there. That gives me this green intersection here. I'll take away the cylinder itself. And then I said, well, I want to kind of see where the cylinder was in the xy plane. So I just did this, and I said, don't extend to 3D. And that's basically it. That's how you do it. All right. Now, another example would be this one I talked about here, the solid inside the sphere and outside the cylinder. So the way I rendered that was, let's bring this one in, like this. So how did I do that? Well, I did the sphere as rho equals 4. I could have done, this is spherical coordinates, rho equals 4. I could have done x squared plus y squared down here. I could have done x squared plus y squared equals 16. I could have put that there, but I just wanted to show spherical. And then what I did was I said, okay, well, the idea is to find the object outside this cylinder in blue, but still inside the sphere. So what I did was I said, well, if I look at it from the z-axis viewpoint, it's hitting at 2. The cylinder is here at 2. So that would be x squared plus y squared is 4. And then, so I let x squared plus y squared, I rewrote the sphere down here. And then I said, okay, the sphere only exists between 4 and 16. 16 is the maximum radius squared of the sphere, and then 4 is the radius, basically, of the cylinder. So I just did that as a piecewise defined function with the sphere, and well, lo and behold, I have that. Let me take out the sphere itself. There we go. So this is it kind of looks like a napkin ring. The sphere without the cylinder inside it. And if you want to make it look more solid, you can just do not translucent. And there you go. So I hope that helps.